Hey everybody, finishing up on our unit here about factoring. We're just going to talk about some special factors, okay? So the first one that I want to talk about is called difference of squares. Difference of squares are interesting because it's going to be a binomial, even though we're probably used to seeing it like a trinomial. So maybe we'd have something like x squared minus 9, and you want to try to factor that. So with x squared minus 9, there's not really pieces here that we can just do like multiply to give you 9, add to give you 0, like that kind of stuff, because it's not a trinomial. Well, what happens here is this is really 1x squared, right? These are both what we call perfect squares. And because they're perfect squares, we can do some special stuff here. So, this only works if these are both perfect squares. And the reason why it's difference of squares is because there's this minus sign here. So if there's a minus sign here, what can happen is we break this apart, and this is going to be, we have to figure out what this is. The square root of that is 3. So this is going to be x minus 3 times x plus 3. And what's interesting is it's still going to factor into binomials. Those are just going to cancel each other out here, because negative 3x when you multiply here, that's going to be positive 3x when you multiply there. And when you add those together, basically what happens is our middle term factors out. I know we talked about those a little bit earlier, but if you see something that looks like this, you just are going to have to know that it's going to factor that way, right? Another one might be something like x squared minus 144, right? And again, if you're not really super good at your perfect squares, this might really be hard for you to notice that it's a perfect square. But you can factor, these are both perfect squares. This is 12 times 12. So this can factor into x plus 12 and x minus 12. And again, we only get that because the minus sign happens, and that's going to happen because both these signs are different. So that's one of the special ones, difference of squares. I would say that one's actually pretty useful. You see those difference of squares a lot when you get to Algebra II pre-calc, and you're going to have to know that you can factor them like this, and then you can start canceling out factors and stuff like that. The other special one is called a perfect square trinomial. Which sounds a lot the same, which I guess it kind of is. Perfect square trinomial. And a perfect square trinomial is basically going to happen if your book puts it like this: a plus b times a plus b. What happens when we just multiply without numbers here, just a's and b's? Well, we're going to have a times a is a squared, a times b, a times b, and b times b is b squared, right? So basically what goes on here is we have 2 of the middle term, 2ab, whatever the a and the b are, and then we have a squared and we have b squared. So if something fits this type of factoring, we're going to have to know that it's the same thing multiplied by itself. Let me give you an example of one of those. We can kind of walk through it a little bit. So, for example, let's say we had x squared plus 14x plus 49. All right. First thing we can identify here is, oh, 49, that looks like a perfect square, because it is, right? 7 times 7. So if we see that, we kind of want to check over here on the first term, our a squared, and this would be 1, right? 1a squared. So 1's a perfect square, 49's a perfect square. So I bet this is a perfect square trinomial. And the way that we can figure it out is if this is a 1, and this would be 7, so if this is 1x for a, and this is 7, that means that our middle term would be 2 times 1x times 7. And I'm getting that right from here. The a is 1x, whatever is squared here is a. The b is 7, whatever squared here is b. And then in the middle here, 2 times a times b. So if you do 2 times x, that's 2x, times 7 is, in fact, 14x. So you basically just have to check that middle term and see, does this actually work? If it does, which in this case it did, then I know that this factor is just going to be x plus 7 squared, right? Or x plus 7 times x plus 7. Usually people will write it this way with the exponent. But if I multiply these two out, I should get x squared plus 14x plus 49. So this thing is kind of, I mean, you can come up with it if you really need to, but it's something that you just kind of have to learn and kind of go from there. So let's try another one of these. And let's see if it's a perfect square trinomial. Let's go with we don't want that one. Oh, I guess we could do that one. All right, let's try this. 16a to the third plus 48a squared plus 36a. So I want to know, is this a perfect square trinomial? Well, the first thing I notice is that they all have an a. So that means that it has a GCF. So we gotta always do GCF first. 36, 48, and 16, also a 4. So if we pull out a 4a here, that's gonna give me 4a squared plus 12a plus 9. And now let's look at this inside part, because I noticed that 9 here is a perfect square, and 4a is also a perfect square. So we can kind of roll with that, right? So if this is, let's see, that'd be 2a squared, right? And this would be 3 squared, like so. We can see if that middle term is going to work out for us, or if it's not going to work out for us. So, let's see here. This would be 2a, 2 times 2a times 3. I'm sorry I wrote that so small. I just realized that I'm literally recording this. I should probably be writing bigger, right? So 2 times 2a is 4a times 3 is 12a. So since that worked, we know that this inside part is just going to be 2a plus 3 squared. Take this part, square it. And just to kind of show you that this is going to get us all the way back here, if I rewrite this out, (2a times 2a is 4a squared, 2a times 3 is 6a, 3 times 2a is 6a, 3 times 3 is 9, and then Add our like terms here, 6a and 6a is 12a. And then you can just multiply 4a through. 4a times 4a squared is 16a cubed. 4a times 12a is 36. No, 48, my bad. 48. A squared, and 4a times 9 is 36a. And you can see that we got right back there. So those are just some special ones, not too bad. We're getting ready for a test again next week. So we're just moving right along. And we're all doing pretty good with factoring in class. I think you guys are doing okay from what I've seen on your homeworks. Well, let me know if you have any questions, and you guys enjoy your weekend. All right?